Okay, geometry students, in this video we will be taking a quick look at a topic called vectors. Vectors are used a lot when it comes to problems dealing with force on an object, okay? And you'll study these more in depth in pre-cal class, all right? Your heading for today is Vectors, Lesson 3.7. Vectors, Lesson 3.7. Please put the date in your notes if you would, please. All right. Vectors 3.7, please include today's date. And let's continue on. Now, you need to write this in your notes, so please copy this down. Vectors are a graphical representation of both direction and magnitude. Okay? Copy that down. Then I'm going to talk about this, okay? A vector is a graphical representation of both direction and magnitude. You see, a vector has two components to it, direction and magnitude. And by the way, when we're talking about magnitude with vectors, we're talking about length, okay? Length or magnitude is the same when you're talking about vectors, all right? I'll wait just another second while you copy this down. Now, here is what a vector looks like. I would encourage you to copy this in your notes. Take a second, please. Quickly draw a coordinate plane, and you'll have a point here at 1, 1, and then put a point at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and up 5. So a point at 6, 5. Go ahead and copy this in your notes. This is what a vector looks like. And really, do you notice a vector is nothing more than an array? Do you see that okay? It's nothing more than an array. Now, hopefully you can see there's an arrow right here. I don't think it's written very well. There's an arrow right here, okay? And it's very important that you see that. Remember, a vector has direction, so we have to have an arrow on the vector. Now, of course, also students, copy this down if you would, please. There are 4 things that a vector has you need to make note of. A vector has direction, okay? I'm going to go ahead and erase these points over here. A vector has direction, a vector has magnitude or length, a vector has initial point, and a vector has terminal point. A terminal point, okay? Please copy this down. I'll wait just a second. A vector looks like this. It's an array drawn on a coordinate plane, okay? It has direction, it has length or magnitude, it has an initial point and a terminal point, all right? Now, please make note on your graph that you've drawn, this point right here, notice the vector is going this direction, okay? So if it's going this direction, that means it ends right here. Thus the word terminal, okay? So this point up here, I don't like that color. You can't see that very well. Let's change that. This point up here is your terminal point. And this point down here is your initial point. Initial means starting, terminal means ending, which makes sense. So this starting point here is called your initial point. This ending point here is called your terminal point. Okay, so here's what a vector looks like. It has these 4 components to it: direction, magnitude, initial point, terminal point. Please make note of all of this, and we're going to continue on. Now, vectors are equal if they have the same direction and the same length. That's really important. I would write that down in your notes if I were you. Vectors are equal if they have 2 things: the same direction and the same length. Okay, so with that in mind, let's look at a problem here. Now I have to give you a second to copy this down, so please go ahead and draw this coordinate plane in your notes. And I want you to go over 3 and up 1, -3, 1 for your initial point, and your terminal point right here will be 0, 3. Okay, Your initial point here is -1, -2, so 1 to the left and down 2. And your terminal point here is 2, 0. All right? But a lot of you are probably still up here on this sentence, which is fine. Please copy this sentence in your note. Vectors are equal if they have the same direction and the same length. Those are the two things that vectors have to have if they're going to be equal. And notice, students, vectors don't have to be drawn in the same place on the coordinate plane. One could be up here, one could be down here, and they could still be equal as long as they have the same direction and the same length. All right? All right, I'm going to give you a couple more seconds, quickly copy this down, and then we're going to take a look at this problem here. We're going to decide. You might say, well, Mr. Earhart, what problem are you talking about? Well, here's the problem. Are these vectors equal? Are they equal? Okay, question mark. Are they equal? So we're going to have to find the distance of each one and see if they're the same, and we're going to have to find the slope of each one because they have to have the same direction, okay? And we'll see if these two vectors are equal. All right, so here we go. Please take some really good notes. Now, students, I expect you to know how to do certain things that I've already taught you. That doesn't mean that I won't go over it again occasionally, but I'm not going to spend time doing all of the steps for you, okay? This is a track 1 class, and you're supposed to remember things that we've learned in the past. So, notice I've written square root of 13. Would you go ahead and write that in your notes, please? That's the distance. Now, we've learned already how to find the distance between 2 points. In case you've forgotten the distance formula and you would like to write it down, please feel free to do that. Here's the distance formula. The square root of x minus x, quantity squared, plus y minus y, quantity squared. Okay, now feel free to write that in your notes. I'm just not going to take all of these numbers and plug them in and do all the work and get square root of 13 and then take all of these numbers and plug them in and do all the work and get square root of 13. Okay, it just takes too much time. So in your notes, please make note that the distance from this point to this point is the square root of 13, and the distance from this point to this point is the square root of 13. So far they're equal. They have the same magnitude or they have the same distance. Okay? Piece of cake, no big deal. Now, how about the slopes? Remember, if they're going the same direction, that means they have to have the same slope. By the way, let me stop right now and say something, and please don't miss this, students. Please listen to me. Well, let me go on to the next page and then make that comment. Okay, so here we go. Make note in your notes, if you were to find the slope of this line, the slope would be 2/3. And if you were to find the slope of this line, it would be 2/3. Now again, I'm not going to take the time to find the slope. If you forget how to find the slope, I'll show you real quick. It's y minus y over x minus x. But students, I'm not going to take the time to work all that out because we've done these quite a few times. Okay, you know how to find the slope of a line. Now, here's the catch. Please watch this carefully, students. If the slope of this vector right here was 2/3, and the slope of this vector was 2/3, however, the initial point was here, and the terminal point was down here, in other words, the arrow was down here, do you see that? Then you would say these two vectors are not equal. Now listen to me. Even though they have the same distance and they have the same slope, they're not going the same direction. One is going this direction, here's the arrow, and one is going this direction, here's the arrow. So anytime you're checking two vectors to see if they're equal, and right off the bat you can see that they're going two different directions, then you know for sure they're not equal. Okay, there's no need to do any work. You can see that. All right. But anyways, back to the problem. Both of these vectors do have their arrows in the same place. They're both going upward. They both have the same distance, square root of 13, and they both have the same slope, 2/3. So are these two vectors equal? Yes, they are. Most definitely. Okay? All right, I hope that makes sense. Now, take a second, if you will, students. Copy this in your notes. I want you to try this one on your own. are these two vectors equal? Well, when I say try it on your own, we're going to kind of do it together, but go ahead and copy this in your notes. Go ahead and copy this in your notes if you would, please. I'll pause a second while you do that. This point here is 0, 0, and this point here is over 1 to the left and up 3, so negative 1, 3. Negative 1, 3. This point here is over 3 and down 2. Over 3 and down 2. And this point here is over 2 and up 2. And of course this point here is at the origin 0, 0, 0. Okay? So go ahead and copy this in your notes. And now, let's think about this for a second, students. The easiest thing to find, if we're going to check to see if two vectors are equal, the easiest thing to find is not the distance. The easiest thing to find is the slope. I mean, it really is. So I'm not going to take the time and find the slope for you because we know how to do that. But if you were to take this ordered pair here, 0, 0, and this ordered pair here, negative 1, positive 3, and use y minus y over x minus x, you're going to get a slope of, hold on one second please, let's see, negative 3 over 1. So make note of that, negative 3 over 1 or negative 3 would be fine. However, if you find the slope of this line over here, you're going to get negative, and it's going to be 4 over 1. So right away, they don't have the same slope. So if they don't have the same slope, then they're not going the exact same direction. I mean, one's kind of like this, and the other one's just a little more, it's a little steeper, okay? And so if they don't have the same slope, they're not going the same direction. Now, understand something here, students. If they would have had the same slope, then you would have to go ahead and find the distance of each line to see if they were equal, okay? But if just one of those two scenarios fails, either they don't have the same direction or they don't have the same slope or the same distance, excuse me, then the two vectors are not equal, okay? So no, these two vectors are not equal because they're not going the same direction. And if they were going the same direction, then you have to check their distance by using the distance formula, okay? I hope all of this is making sense. Now, understand also, students, that vectors can be moved and still be equal. All right, let me explain this to you. Vectors can be moved and they can still be equal. Now, watch this carefully. Please watch this, students. I would not take notes on this right here. I would just watch this, okay? Now look. Sorry, students. I would copy this in your notes. I'm going to wait just a second. Copy this in your notes. Vectors can be moved and still be equal. And of course they can. That's very obvious, okay? Vectors can be moved and still be equal. Copy that down, please. Vectors can be moved and still be equal. Now watch. If I pick this vector up and move it to right here, it's still the same vector, it's just in a different place. Look, let me show it to you like this. Let me get a quick copy of this line, okay? Hold on one second here. Now watch this carefully, please. Alright, now here's where the vector is originally, right there. Alright, now, if I pick, I'm going to slide this up just for, I have a reason for that. Just trust me on this, students. I'm going to go like this, there. Alright, now, if I picked this vector up and moved it right here like this, that's still not a good example. Hold on one second, students. Sorry about that. If I picked this red vector up and I moved it to right here, do you know why they're still equal? You should. We just talked about it. They both have the same what? length or magnitude, and they're both going the same direction. In other words, they have the same slope. So students, anytime you can pick a vector up and move it so that its initial point is at the origin 0, 0, that's a real good thing to do. Okay, and so this vector right here is the exact same vector as this vector right here. All right, now let me go ahead and tell you a couple of things you don't need to write down yet, but you're going to write down in a second. When a vector is written with its initial point at the origin, we call that writing the vector as an ordered pair. And what we do is this. Watch this carefully, please, students. Again, don't take notes on this. Just listen. I'm going to give you a bunch of notes on this in a second. But see, this terminal point right here is over 3 and up 2. Well, I write that ordered pair inside these little arrow looking things like this. And what that means is I have a vector whose initial point is at the origin and whose terminal point is at 3, 2. Okay, and we call that writing the vector as an ordered pair. Now let's go ahead and talk more about that, okay? But understand, please listen to me, students. Any vector, anywhere on the coordinate plane can be picked up and moved so that its initial point is at the origin. Any vector, okay? And let me show you how to do that, all right, very quickly. Whenever we move a vector so that its initial point is at the origin, we call this writing the vector as an ordered pair. Now, we really don't call it that. In pre-calculus, we call it component form. But in this class, or this textbook, they use the phrase writing the vector as an ordered pair. So that's what we're going to call it, okay? So make note of this in your notes. Whenever we move a vector so that its initial point is at the origin, like we did back here, okay? Here's the initial point right at the origin, 0, 0. Whenever we do that, we call this writing the vector as an ordered pair. Writing the vector as an ordered pair. All right, now let's continue on. To be honest with you, to do that is a really simple procedure. We just use a simple formula, and here's the formula. This is so easy, students. So let me stop and say this. Anytime you're given a vector and you want to write it as an ordered pair, use this formula right here. TP, write this down please. TP stands for terminal point. IP stands for your initial point. And look what you do. Students, you just simply subtract the two ordered pairs. And I'll show you how to do that in a second, okay? You just subtract the two ordered pairs. Now, here's where most students mess up. They forget to put the terminal point first, and they put the initial point first, which is a normal thing to do, but it's wrong. You put the terminal point first, and then minus the initial point. And if you'll do that, that's just like picking the vector up like we did right here. Sorry, students. Hold on one second. And moving it right here. Okay, so with that in mind, just trust me here. Let's go ahead and practice this, okay? So let's demonstrate. Let me demonstrate how this works, and then I'm going to have you try one on your own. Okay, now students, listen to me. There is no need for you to draw a coordinate plane. I'm just doing that so you can see it. You do not need to do that. You can if you want to, but you don't need to. Now I want to take this vector and I want to write it as an ordered pair. We're going to assume, go ahead and copy this problem down. Go ahead and write down the ordered pair -1, -3, and the ordered pair 5, 4. And we're going to assume the first point given to us is the initial point, and the second point given to us is the terminal point. And again, if you want to graph this, you can, but you don't have to. I'm just doing that because I want you to see it, okay? So here we go. -1, -3. and then over 5, 1, 2, 3, 4, 5, up 4, 1, 2, 3, 4. There we go. All right. So here's my vector. And for the third or fourth time, you don't have to do this. Okay, I'm just doing this so that you can see what I'm doing. Okay, there's my vector right there. All right. Now, what I'm going to do, students, I'm going to pick this vector up and move it so its initial point is right there at the origin, 0, 0. And I'm going to do that by using this formula right here. It's so easy to do. Now, remember the formula. You put your terminal point first. So my terminal point is 5, 4. Please take notes on this. Your terminal point comes first, TP, and then minus your initial point. Well, here's your initial point, -1, -3. And when you're done, put these arrows, okay? You'll have out, excuse me, you'll have out the vector written as an ordered pair. So here we go. 5, this is your initial point here. 5 minus -1, that's 6. It's easy to do. 4 minus a -3. That's 7. So let's go plot that point real quick. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 right here. So remember, the initial point is at the origin, okay? And the terminal point is right up here. Well, let's see if it worked. Let's grab this vector and let's move it. Look at that. Booyah, okay? Perfect, okay? All right, so listen. This vector right here that has an initial point at -1, -3, and a terminal point at 5, 4, this vector right here is the exact same vector written like this. And when you see those arrows and this ordered pair, then you automatically know the initial point is at 0, 0, and the terminal point is at 6, 7. In this case, 6, 7, okay? So not too difficult. I'm just going to pause for a second and let you think this through, okay? So what we're doing, what this is called, is writing a vector as an ordered pair, okay? All right, let's go ahead and continue on. Now I want you to try this one on your own, okay? So I'm going to pause a second. We're going to assume this is our initial point, and we're going to assume this is our terminal point. And here's what I want you guys to do. I want you to write this vector as an ordered pair, okay? So go ahead and do that now, students, on your own. I'm going to pause a second. I'm just going to sit here and wait. I want you to use this formula right back here that we just learned, right here. Terminal point minus initial point gives you the vector written as an ordered pair. And I want you to use that formula, and I want you to write this vector as an ordered pair. All right? Go ahead and try that on your own. All right, your terminal point comes first. So 3, 5. Your initial point comes 7, comes second, which is 5, 8. And here we go. 3 minus 5, -3. Excuse me, that's not right. -2. And 5 minus 8, comma, -3. So, please listen to me carefully, students. Don't miss this. This vector right here is the exact same vector as this vector here, okay? The difference is this vector here is written with an initial point and a terminal point, and this vector here is written as an ordered pair. Okay, that's the difference. That's the only difference. All right, let's continue on. Okay, students, let's put the last two things that we just learned together in one problem, okay? Let's take two vectors and we're going to write them as an ordered pair, and then we're going to see if they're equal, okay? So let's take two vectors, write them as an ordered pair, and then see if they're equal. All right, so here we go. Take some really good notes, please. All right, now you're learning some new notation. I'll write it real big here so you can see it. This line here, students, that has like a half an arrow on it right here, that's the symbol for vector, okay? So when you see that symbol right here above the AB, that means vector AB. Okay, so vector AB has point A, 1, 2, and point B, 5, 8. Vector CD has point C, -3, -4, and point D, 3, 5. Now, we're going to assume the first point is our initial point, and the second point is our terminal point. Now, here's what I want you students to do. I want you to go ahead and quickly write this vector here as an ordered pair. All right, so here we go. We're going to take terminal point. Take some notes on this, please. We're going to write this vector right here as an ordered pair. So we're going to take our terminal point, 5, 8, minus our initial point, which is 1, 2, and we're going to get out this right here. Okay, so 5 minus 1, 7, 8 minus 2, 6. Now, I would like you in your notes to graph this vector. So, this is the vector over here, written with an initial point and terminal point, and then we rewrote the vector as an ordered pair. So let's see what we have. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So there we go. The vector is going to start here and go right there. Okay? Alright, now let's take this next vector here, and of course this is your initial point and this is your terminal point, and we're going to go ahead and write this vector here as an ordered pair. So we're going to take the terminal point, which is 3, 5, minus the initial point, which is -3, -4. And let's see what we have. We have 3 minus a -3, which would be 6. 5 minus a -4. And by the way, if you struggle with your sign numbers, then use a calculator to help you. There's nothing wrong with that, okay? 5 minus a -4 would be 9. So 6, 9. So I'm going to go over 6. 1, 2, 3, 4, 5, 6, and up 9. 7, 8, 9. So about right here. Students, do you not see? Well, first of all, let me stop right there. Hopefully you understand what I've done. I quickly took vectors that were written with an initial point and a terminal point, and I wrote them as an ordered pair. Again, students, for the third or fourth time, when you write a vector as an ordered pair, you're basically saying this right here is my terminal point, and what's your initial point? 0, 0. Students, now look at what we're supposed to do. Now we're going to see if they're equal, okay? Look how easy it is to see if two vectors are equal once you write them as an ordered pair. There's no work to do at all. It's obvious these two vectors are not equal. It's impossible. Students, look, if they were equal, they would have to fall right on top of each other, just like that. Because they would have to have the same length, and they would have to have the same direction, which means the same slope, so they'd have to fall right on top of each other. So it's really helpful to learn to take vectors and write them as an ordered pair, because when you do that, it's so much easier to compare them. Okay, it really is. All right, so are these two vectors equal? No, they are not equal because they don't have the same direction, and not only that, they don't have the same length or magnitude. Okay? All right, I hope this is making sense. Let's go ahead and continue on. Now let's move on. You can also add vectors. It's a very easy procedure, and it can be done graphically or mathematically. Okay? Now in this lesson here in geometry, we're just going to learn the mathematical method. We're not going to worry about the graphical method. Okay? But because it's so easy, I'm only going to give you one example. Okay? Just one example. And so here we go. All right, copy this in your notes, students, if you would. V plus W. Now here's another way to write vectors. We can say vector V is negative 2, 7, and vector W is 7, 12. Now students, please listen to me. Notice that when you add vectors, they're written as an ordered pair. Okay? That's really, really important. So on a test or a quiz, if I give you vectors that are written with an initial point and a terminal point, and I ask you to add them, the first thing you'll want to do is rewrite your vector so that it's written as an ordered pair. Okay? Because that's the easiest way, really the only way to add these two vectors. Okay? All right, so with that in mind, here we go. Let's go ahead and take a look here. We're taking vector V plus vector W, and we're adding them. So it's so easy, students. V plus W equals negative 2 plus 7, 5, 7 plus 12, 19. It's just that easy, and that's why we're only doing one example. This is really, really simple, easy math, okay? So adding vectors can be done, and you add vectors when they're written as an ordered pair, and it's really, really simple to do. Okay? Now, again, moving on, you can also multiply vectors. Now listen to me carefully. It's called taking the dot product of vectors. Okay? It's called taking the dot product of vectors. Now, you might want to write that down. You don't necessarily have to, but understand we call it the dot product of vectors. When you find the dot product, listen to this. You get out a number, not a vector. Now remember, a second ago we added two vectors. And when we added two vectors, we got out another vector. We got 5, 19, correct? Sure we did. That's not the case when you're multiplying vectors. When you're multiplying vectors, you get out a number, not a vector. Let me show you real quick, okay? And like adding vectors, it's so easy to do. Once again, I'm just going to give you one example because it's really simple to do, okay? All right. Now this little dot right here, excuse me, hold on a second. This little dot right here, students, means we're going to take the dot product of these two vectors. We're going to multiply these two vectors together. So students, here we go. We're going to take vector V, which is negative 2, 7, and vector W, which is 7, 12, and we're going to find the dot product. Now it's really, really simple, and here's what you do, students. You take your first number times your first number, so negative 2 right here, times 7, and you get a negative 14. Then you take your last number here and your last number here, and you multiply those together, and you get a positive 84. And then you always add these two numbers. Always. You never subtract them. You never multiply them. You add these two numbers together. So a negative 14 plus a positive 84 would be 70. So there you go. That's the dot product of V and W, V times W. Now, Mr. Earhart, is kind of a waste of time. What does that do for us? Well, you're going to learn later in pre-calculus, if you take that class, that the dot product does a lot of things for you. One thing that it does is it helps you find the angle measurement between two vectors, okay? And it does some other things also that are really helpful and really neat. But for right now, we're just going to be learning how to add vectors and how to find the dot product of two vectors, okay? One other sentence I'd like you to write in your notes, please. Let me get another drink here real quick. I would like you to write this down, students. By the way, when the dot product of two vectors is 0, that means the two vectors are perpendicular. So if you're ever given two vectors and you multiply them together or find the dot product and you get out 0, then you know right away those two vectors are perpendicular. I'm going to pause a second. I would definitely write that in your notes. Okay? And that's it, guys. I hope this video has been a help to you. Just a quick little study in vectors. If you have any questions, don't hesitate to call or email.